Now, after understanding the formation of different molecular species by the Lewis representations, let us do the exceptions of the octet rule. So we have been doing the molecular species, and we are trying to understand them as per the octet rule, or we can say the electronic theory of the chemical bonding. But now let us see the exceptions of this rule. Now we know the molecular species in which the atoms are combining and still their octet is not complete, but still they combine and they form molecular species. Now let us take first examples in which the octet is incomplete. Let us take example of molecular species with even number of electrons. Like we have beryllium chloride, we have BF3, we have boron trifluoride, boron trichloride, zinc chloride. Now all these are AlCl3, aluminium trichloride. In all these molecular species, in this case, let us take each one of these one by one. Beryllium is forming 2 bonds with 2 chlorine atoms. Beryllium is having only 2 valence electrons. Since it's both of these electrons are shared and it is forming 2 covalent bonds with 2 chlorine atoms, it is left out with only 4 electrons. Its octet is not complete, but still it combines. Let us take BF3, boron trifluoride. Boron has 3 valence electrons. That's why it's combining with 3 fluorine atoms like this. Now, what happens is, in doing so, it acquires 6 electrons. Fine, but still, its octet is not complete. Same is the case we notice in the case of what? Boron trifluoride. Boron combines with 3 chlorines. It's belonging to the 13th group. It's having only 6 electrons. 2, 2, and 2 makes it 6. Same is the case with the aluminium trichloride. AlCl3, 6 electrons. Same is the case with the zinc chloride. Zinc is belonging to, of course, the 12th group. It's having 3d10-4s2 configuration. It combines with 2 chlorine atoms. It's having only 4 electrons. So these are the exceptions. These are the examples in which the octet is not complete, but still they are formed. And remember, in these all molecular species, the central atom is having its incomplete octet with even number of electrons. Let us take now the example where we have odd number of electrons and the octet is incomplete. Odd electron molecular species. The examples are NO2, nitrogen dioxide. Each nitrogen we know is having 5 valence electrons. Now out of these 5, 2 gets engaged with 1 oxygen atom, and then we have to know this. It cannot extend its octet. One is forming a dative bond with another oxygen atom, and we are left with only 1 electron. Now, we know this oxygen will be having 3 lone pairs. This oxygen will be having 2 lone pairs. So this nitrogen is having only what? 2, 4, 6, and 1, 7 electrons. So this is an example of what? Odd electron molecular species, which make this molecular species paramagnetic in nature and very reactive. Another example we can take is of nitric oxide, NO. In this nitric oxide, we know nitrogen has 5 valence electrons. Oxygen needs how many? 2 to complete its octet. So nitrogen and oxygen combine like this. In doing so, nitrogen already acquires its 8 electrons, so its octet is complete. But the problem lies with nitrogen. The nitrogen is having what? 2 shared with the oxygen, so it is left out with 3 electrons, and that is how it is having 7 electrons. This odd electron makes it what? Having odd number of electrons, and that is why it falls in the odd electron molecular species. and it will be again paramagnetic in nature, very unstable, very reactive. But all these are the examples where we have odd number of electrons with the central atoms. Now, let us take examples where we have electrons the more than 8. So octet is not there, octet is already there, fine, but the number of electrons with the central atom are more than 8. Now let us take those examples in which the central atom is having more than 8 electrons. Those are exceptions to this normal your octet rule, and we call them as expanded octets, the molecular species with the central atom having expanded octet. The examples are like we can have PCl5, phosphorus pentachloride. In this, we know phosphorus belongs to 15th group. It is having 5 valence electrons. All 5 are shared with 5 chlorine atoms. So when all these 5 are shared with 5 chlorine atoms, remember the phosphorus requires 10 electrons. So it's an exception to the octet, and we call it expanded octet. This is the 10 electron species. Don't bother about the structure of this molecule, that you will learn later on. Only thing is that we need to know now the phosphorus is forming 5 covalent bonds with 5 chlorine atoms. Structures will be done later on. It is just because I'm knowing it, I'm drawing it, otherwise you can draw it in any way. Of course, when you'll be doing the testing, you'll be knowing its structures. Now, the other example we can take is SF6, sulfur hexafluoride. In this molecular species, sulfur we know belongs to 16th group. It has 6 valence electrons. All are shared with 6 fluorine atoms, like this. So sulfur is having 12 electrons. So this is again is an exception to this octet rule, expanded octet. Let us take another example. Let us take example of IF7, iodine heptafluoride. Iodine has 7 valence electrons. It's belonging to 17th group. So all its 7 electrons are shared with 7 iodine atoms. So that is how iodine is having 7 electrons around it. It's like this. So iodine is having 14 electrons. So these all are the expanded octet molecular species.